This video is on factor by grouping, but I want to review something with the GCF before we get into the actual factor by grouping. Remember, the GCF of a polynomial can actually be a group of terms. If I look at this first example, 3 times a plus 2 quantity squared minus 5 times a plus 2, there's only two terms here. It's a binomial, right? You've got to look big picture. And those two terms have something in common. They have the group of a plus 2 in common. Both of them have that factor in common. So while I only have two terms here, they do have a GCF. It just happens to be something a little bit bigger than what we've been used to dealing with. Now we can use substitution to create a more simple problem to help us explain this. Let's pretend like the group a plus 2 is equal to m. So I'm going to replace wherever I see an a plus 2 with an m. That leaves me with 3m squared minus 5m. Now I can clearly see that it's a binomial, and that binomial has an m in common. If I factor out that GCF of m, I'm left with 3m minus 5. That we're used to dealing with. It's not a big deal. Well, by replacing the m, which is something I need to do, make sure I do, and putting back the a plus 2, I can also see that the a plus 2 is indeed a GCF just like that m was, right? And so I can use substitution to help me solve a more simple problem. What I would do here, if I get down to something like this, is I would distribute that 3 in there and collect like terms and make it a little bit more simple. So let's move up here. I have a plus 2 in that first group. 3 times a is 3a. 3 times 2 is 6, positive 6 minus 5. And so that leaves me with a plus 2 times 3a plus 1. And I just can simplify that, and it looks like something that we're used to dealing with. So what I want you to see is that even in this group, while I have a binomial, and that binomial has a GCF, that GCF can potentially be a group. And so that just leaves me with this set of factors right here that I then simplify to make sure that I've collected all of my like terms and that it looks like something I'm used to dealing with. Now remember, our goal of factoring is to create a product, right? So no matter what, I follow my simple steps, and if I don't read your product, I haven't done something right. Right? Our goal is to create a product. Looking at example 2, I have two terms. I need to look for GCFs, put it in descending order, take out red flags, everything like I've been doing. If I were to actually truly put this in descending order, it would be a plus 3 quantity squared plus a plus 3, right? And if I use substitution to solve a more simple problem, I can clearly see if I let p equal the group a plus 3, I can clearly see that I have p squared plus p to the first, and that's in descending order. If I were to factor my more simple problem, I would pull out a p, and I'm left with p plus 1. Well, the same thing happens if I'm looking here. These two terms have an a plus 3 in common, so I'm going to factor out an a plus 3, and I'm left with an a plus 3 and a 1. From in here. You can replace the p with the a plus 3 and see you get the exact same thing. By collecting like terms in here and simplifying, I get a plus 3 times a plus 4 as my final product. And remember, that's the goal, reaching a product. Looking at example 3, I have the group y plus 2 in common in this binomial. And so I'm going to factor out y plus 2 out front because that is in descending order, and I'm left with a with a y plus 2 minus a 3 times a 1, or just a 3. And so I have y plus 2 times y minus 1 when I collect my like terms. Go ahead and see if you can use substitution to solve a more simple problem by letting, let's say we let m equal the group y plus 2, and see if you can get the same thing. All right, these things can get even bigger. Now, not only do I have the group in common, I have a binomial in common, but I also have coefficients and regular variables. So I'm going to start with the coefficients. Between 6 and 9, they have a GCF of 3. When I look at the A's, both of these terms have an A in it, and both of these terms have at most one B. They also both have the group x plus 2y. That is a huge GCF, but the process stays the exact same. I'm going to use brackets to show that I'm dividing this GCF out of these two individual terms. And let's just do one thing at a time. We're going to start with the first term. 6 divided by 3 is 2. A squared divided by A is A. B squared divided by B is B, and x plus 2 divided by x plus 2 is 1. I don't need to put that 1. Now I'm going to move, and I'm going to do the second term. Negative 9 divided by 3 is negative 3. A divided by A is 1. I'm not going to write that. B divided by B is 1. I'm not going to write that because 1 times anything in itself is itself. And then x plus 2 divided by x plus 2y is also 1. And I can close my brackets. Now I just need to clean it up, see if there's anything that I can do to make it look a little bit prettier. There isn't anything I can do inside the parentheses, so what I'm going to do is instead of writing the brackets, just write the other set of parentheses. And here is the product that is created when I factor this weird binomial that I had to start with. Notice it only has 2 terms. This is perfectly fine answer to reach to because I've reached my goal of getting a product. Factor by grouping is a method of finding common binomials that terms have together. We use factor by grouping when we start with 4 terms. And so, as always, we always want to double check how many terms do we have. When you have 4 terms, we're going to use this process of factor by grouping. The first step in factor by grouping is to literally group the first 2 terms together using parentheses. And then you're going to group the second 2 terms together using parentheses. Now, where you have to be careful is that this says negative CD. That negative needs to go with the CD in the parentheses. And so what I do is I add the opposite, and that way I can clearly see I still have 4 terms. I've just grouped the first 2 together and the second 2 together. Okay, I made this a little bit bigger so it's a little bit more clear to write. Now what I'm going to do is find the GCF of the first group, and I'm going to factor that GCF out. Between 2C and 2D, the GCF is 2. When I factor out a GCF out of this first group, I'm left with a C plus D. Now I'm going to factor out the GCF of the second group. Between negative CD and negative D squared, not only do I have a red flag, but I also have a D in common. So I'm going to pull out a negative D, and that leaves me with C plus D. Let's double check that really quickly. Negative CD divided by negative D is just positive C, and negative D squared divided by negative D is positive D. What I've now done is I've gone from 4 terms to 2 terms. And these 2 terms are what we've been doing in the past couple of slides. I now have 2 terms that have a common binomial, and I'm going to pull that binomial out front, and I'm going to write what is left. And so factor by grouping is an easy way to factor a 4-term polynomial. Go ahead and pause and see if you can do these 2 on your own. The steps are over here for you. In example 7, I'm going to group the first 2 terms together, and then I'm going to make sure that I take the sign with that middle term if I need to. It's positive, so I don't need to do anything special there. Then I'm going to look for the GCF of the first 2 terms between PQ squared and TQ. They have a GCF of Q. That leaves me with PQ plus T. And between the second grouping, 2PQ plus 2T, I have a GCF of 2, and that leaves me with PQ plus T. I have to be really careful here to make sure that I go from 4 terms to 2. right? So in all factor by grouping, you go from 4 terms to 2. So I have to make sure that I put that plus sign in there. Otherwise, it looks like I get to a product right away. You go from 4 terms to 2 terms, then to 1. If you don't have 2 terms, you didn't do it the right way. So now I can look at these 2 terms and see that I have the group PQ plus T in common, and I'm left with Q plus 2. Looking at example 8, I'm going to group the first 2 together. And taking care to make sure that negative goes with the xy, I'm going to add the opposite and group the second 2 together. The GCF between that first 2, notice here, sorry, I still have 4 terms. The GCF between the first 2 terms is an x, and I'm left with xy minus a. The GCF between the second 2 terms doesn't have any, but what I do have is a red flag. And so I'm going to pull out a -1. And then that leaves me with a positive xy minus a. And now I have a double check and I make sure I have 2 terms, and I do. Now what do those 2 terms have in common? They both have the group xy minus a. You can kind of see here how essential it was to take out that red flag. What am I left with? X from the first group and the -1 from the second group. And now I've reached one term, or my product.